Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back to my channel. For this video, I will deliver one topic in physics, for senior high school. In the topic about fluid mechanics, especially we will discuss about static fluids, and then I will deliver the topic using this book of Zambach thermodynamics. Before I start the explanations, you can subscribe my channel and then turn on the notification for update other videos from me. Okay, let's start our topic today, fluid mechanics, especially about static fluid. Okay, when we discuss about static fluid, we need to understand one quantity that we often use this quantity in static fluid, that is about density. What is density? Density of a substance is the mass of unit volume of that substance. The density of iron, for example, is the mass of 1 meter cube of iron. Okay, and then density is defined by the formula rho equal to mass over volume. Mass over volume. And then two commonly used units for density are kilogram over meter cube. This one the SI unit. This one the SI unit for density. And then sometimes people using gram over centimeter cube. Okay, for example, the density of water is raw water is equal to 1 gram over centimeter cube is equal to 1000 kilogram over meter cube. This is density and its unit. And then you have to know that the density here is a characteristic of material. Characteristic of material, or sometimes we can call it as intrinsic property. Okay, what does it mean if one quantity known as characteristic of material or intrinsic property, that quantity always constant? Constant. For example, if you see this formula, mathematically, if you increase the mass, for example, from 5 kilogram and then you increase become 10 kilogram, mathematically the density here, this one symbol for density rho, this is taken from Greek letter rho. Mathematically, if you increase the mass, the rho will increase too, but this is not. Why? Because the rho or density here is a characteristic of material. When you increase the mass, the volume will increase too, and then give the constant value of rho. This one always constant. It means different substance, it has different density. For example, right here, water has density 1000 kilogram over meter cube. So everywhere water, it has density 1000 kilogram over meter cube until the water change become another substance. If still water, it has that density 1000 kilogram over meter cube. And then I hope you can convert the unit of density, for example, from kilogram to gram over centimeter cube. I will show you this one, that the 1000 kilogram over meter cube equal to 1 gram over centimeter cube. Where is come from? You can use like that. This one gram, this one centimeter cube. 1 kilogram, is equal to 1000 gram. It is move down 3 steps. This one kilogram, decagram, and then this one gram. Move down 1, 2, 3. Move down 3 steps. It means if move down 3 steps, it means times by 1000. Or 10 power 3. So if this 1000 become 1 million, 1 million in power of 10 is a 10 power 6. over meter cube to centimeter cube. It is moved down 2 steps. Meter cube to centimeter cube. Okay, this one moved down 2 steps. 1, 2. Okay, if moved down 2 steps for volume units, this time multiply by 10 power 6, yeah. So in here 10 power 6, if you cancel, become 1, yeah, 1 gram per centimeter cube. I hope you can understand this because this one easy. Okay, let's continue. Okay, there is an example 1.1. We read together. Calculate the mass of solid iron sphere that has a diameter of 4 cm. Take the row of iron. The density of iron is a 7.9 gram per centimeter cube. It's not good number. Okay, but no problem. The solutions. First, find the volume, because from the questions, this one, the object is a solid iron sphere. We have to find the volume of sphere. Volume of sphere is equal to 4/3 pi r cube, yeah. 4/3 pi r power of, this is a mistake, yeah. If you following the book, yeah, the r is a 4. In here is not diameter but radius, yeah. This is wrong. It's not diameter. It should radius, yeah, radius 4 cm. If the radius 4 cm, this one's true. And then we got the volume is a it is rounded to 168 centimeter cube, yeah. And then from definition, the formula for mass, yeah, if the row mass over volume, so the mass is row times volume. The row is 7.9 from here, and then the volume is 268. And then if you calculate, you will find it is rounded 2117 gram, yeah. Okay, second example 1.2, the density of mixtures. We read together. 5 gram of ethyl alcohol is mixed with 5 gram of water. Find the density of the mixture. Take the row of water 1 gram per centimeter cube and row of alcohol 0.8 gram per centimeter cube. And then if we're using definition of density, this one easy. For the mass, you just edit the mass of alcohol and mass of water. And then for volume, also the same. You add volume of alcohol plus volume of water, and then you will get easily is a 0.89 gram per centimeter cube. This one also already rounded, yeah. Then the unit conversion I have discussed before. This one also important. The other unit that we often to use when discuss about fluids, 1 liter equal to 1 decimeter cube. And then I believe you have learned in math, so this one is not difficult for you. And then 1 milliliter will equal to 10 power minus 3 decimeter cube, or 1 centimeter cube, yeah. So we can replace this one. There is a table material with their own density in SI unit, kilogram per meter cube, and in other unit, gram over centimeter cube. And then you can replace by the centimeter cube here become milliliter, yeah, because 1 milliliter equal to 1 centimeter cube. So you can say the water has a density 1 gram over milliliter. Also the same for other, yeah. And in this book also show you how to convert the units, yeah, from gram over centimeter cube to kilogram over meter cube, yeah. And then this one also there is an explanations that the density is intrinsic property, yeah. You can read by yourself. I have discussed it before, yeah. Next, the other quantity that we have to understand when we discuss about static fluid is pressure. Pressure in daily life, I believe you have familiar with this term pressure, but maybe it has different meaning. the pressure in your daily life and the pressure definition in physics. Yeah. Okay, in physics the definition of pressure is the perpendicular force per unit area. Yeah, this one the definition of pressure in physics. So it has different definition of pressure in your daily life. Yeah, there is a figure 1.1 show to us the definition of pressure. If we have an area, I will use in the blue color certain area, and then there is a force acting on it. Yeah, there is a force acting on it, but the force is not perpendicular. This is, yeah, the F is not perpendicular, so we have to find the force that perpendicular with the area. Okay, let's say that the force making angle with the area, let's say this one, this line as a normal, and then for example the force acting on the area with certain angle theta, like that, is not perpendicular, so we have to find the force that perpendicular with the area. You can use vector decompositions to find it. This one is a fx, yeah, and then this one fy. Fy is the force that perpendicular with the area, so we take fy to the definition of pressure. Yeah, so if we bring here the pressure equal to fy of f the perpendicular with area over the area itself. Yeah, or we can use like that, fy over area. If we connect it by its angle, so the f here is a f cos theta over area. And then what is the unit for pressure? The pressure units we can see from the quantity at the right side. There is force. Force unit is a Newton. Yeah, and then area's unit is a meter square, and then the unit of pressure easily to understand is a Newton over meter square. And then it has special name for Newton over meter square, that is Pascal. Okay, Pascal is a unit for pressure. Different with the density. The density doesn't have special unit, just kilogram per meter cube. But for pressure, it has special unit, that is Pascal. When we talk about pressure, we talk about something above the object we observe. For example, if we observe about floor, and then if you stand on the floor, we can say you press the floor, yeah, because you above it. So if we talk about pressure, we talk about something above that object we observe. Yeah, in everyday life, there is something above us, that is air, yeah, gas. This is the object above us because the air or the gas has mass, it has weight, and then weight is a force, and then because of that force, and then our body has certain area, and then we feel pressure from the air, from the gas above us. Yeah, and then the name for the gas or air that press us is the atmospheric pressure. Atmospheric pressure, or pressure exerted by weight of the gases in the atmosphere. Yeah, because the atmosphere is continuously pushing down upon all things on earth, including earth's surface and then also the human. In here there is another knowledge that the pressure has other units, not only Pascal, not only Newton over meter square, but also ATM and centimeter Hg. So the relation between those units you can see from this book, that 10 over 5 Pascal is equal to 1 ATM is equal to 76 centimeter Hg. Yeah, what is H here? H here is a mercury. Why the 10 power 5 Pascal equal to 76 centimeter Hg, and where is come from? I will explain later. Yeah, and then atmospheric pressure, it has symbol P0, yeah, denoted by P0. This is atmospheric pressure, and there is a picture that can explain to us there is a relation between the position and the pressure on it. Yeah, for example, if you see from the picture, there is a picture of sea and then a mountain. Yeah, and then at the sea level you can see the pressure at the sea level is 100 kilopascal. As the position move up, yeah, the pressure is decreasing until, for example, if you focus on two positions at the sea level 100 kilopascal, and then at the top of mountain is 27 kilopascal. This is also the reason why if you on the top of mountain you will feel difficult to breathe rather than you are at the sea level. Yeah, at the sea level easier to breathe, but on the top of mountain more difficult to breathe, because at the top of mountain the pressure is smaller than at the sea level. Okay, why at the top of mountain is the pressure is smaller than at the sea level? Because the mass of gas or the amount of gas is decreasing. Yeah, remember, if we talk about pressure, we talk about the object above it. I will draw, you are at the top of mountain, so you will feel the pressure from the gas above you. Yeah, I will take like that. This is the gas above you, so you feel the weight of this object, you feel the pressure of this gases. Yeah, but different if you are standing on the sea level like that, you will feel the gas or the pressure of the gases like that. I will choose different color. You will feel this pressure from gas. This is the amount of gas. Yeah, you will feel this pressure from this gas. Yeah, and then the amount of gas is more than at the top of mountain. Also the mass and weight also greater, and then obviously the pressure will also greater when you are standing on the sea level rather than you are standing on the top of mountain. It's why in here you will feel more pressure. When we talk about pressure, we have to understand that every object can give pressure. Fluid that we discuss in here in this video, also it can give pressure. And then the fluid, you have to know the fluid. If we talk about fluid, we talk about two substances, that is gas and liquid. First one, we have to discuss about liquid pressure. Yeah, liquid pressure, it has differences with the solid pressure. Yeah, if you see figure 1.3, this is shows solid pressure. Yeah, solid transmit force in the same direction. Okay, when struck by a hammer, a nail exerts the same force upon the wall in the same direction as the hammer. Yeah, the hammer give pressure to the nail and the nail give pressure to the wood. But the important one in here, that the force acting on it is the same direction, directed to the right. So the pressure also same, only one direction, following the direction of force. So the pressure also directed to the right. But if the pressure is not vector quantity, even it has direction, we are following the direction of force, but the direction of but the magnitude of pressure is always positive. Why? Because if the force directed to the left, yeah, the pressure also the same. Yeah, also the same, directed to the left. So everywhere the pressure is positive. Yeah, following the direction of force. So the pressure is scalar quantity, it's not vector quantity. Different with the solid pressure. If liquid pressure, we read right here, liquid, we talk about static, so the liquid is in equilibrium at rest. Liquid in equilibrium transmit pressure equally in all directions, as shown in the figure 1.4. We have container here, and then the container containing water, for example liquid. Yeah, let's say the liquid is the water. There is a liquid right here, and then if we put something inside the container, a cube for example, and then the cube will press by the liquid in all direction, yeah, from up, from bottom, from right, from left, from in front, from behind. Okay, and the liquid will press in all directions. And then the second picture, there is also the example that the liquid press in all direction. If you have balloon and then the balloon containing a liquid, and if you try to push the balloon like that, this is your force, and then the shape will be like this. Why? Because the liquid press the balloon in all direction. Okay, and then this definition known as Pascal principle. And then how the relation of liquid pressure with depth. Think about a container filled with water. Water push against the surface of the container but cannot apply force sideways along the surfaces. So this one give understanding to us that the force acting on the container always perpendicular, perpendicular like that. This is the liquid pressure is perpendicular to the surface, yeah, because the force acting on the surface is perpendicular, and then the pressure also the perpendicular. There is no sideways force. There is no sideways force, for example, like that. There is no force like that, but the force will perpendicular to the surface. This is the force. Okay, there is no sideways force. Okay, the liquid pressure at the bottom of the container caused when the weight of the liquid can be found. Obviously, consider a cylindrical container as in figure 1.7. Yeah, we are trying to define the pressure and its relation with depth. Okay, this is our formula. P equal to F over A. This is pressure from liquid. F here replaced by the weight of liquid, and then over A, the weight is M over mg over A. The mass here we can substitute by rho times V, yeah, and then rho V itself is A times H, area times the height. Yeah, this is the volume, and then you can cancel the A, and then you got the pressure from liquid is equal to rho GH. Yeah, rho GH. So depend on the density, different substance, different pressure, depend on the G. Where is the location? Gravitational acceleration depend on the location. Yeah, if on Earth 9.8, if on Mars, etc. different numbers. If on the Moon, different. And then the H here is not height, it's not the position from bottom, but this one is a depth. Depth means the depth measured from surface. Yeah, from surface. So the surface is a 0 point. Yeah, 0 point. If you want to measure the depth is 2 meter, it means 2 meter from surface. Yeah, for example. Okay, so if we do the experiment using water, for example, and then we do it on Earth, so the pressure change only depend on depth. If the liquid is water, we doesn't change it, and then the experiment we do it on Earth, it is constant, the G, and then the pressure only depend on the depth. Yeah, because the container containing water, it has different depth, obviously. So if I want to throw the pressure in here as a P1 and then pressure here P2, you can easily understand that P2 is greater than P1. The pressure on the second positions is greater than the pressure on the first position. Why? Because at the second position the depth is more than the first positions. Easy. And then if you want to using units analysis, the rho units is kilogram per meter cube. The gravitational acceleration units is a Newton per kilogram, and then the depth unit is a meter. You will get Newton per meter square. This one unit for pressure, Pascal. Yeah, Pascal. Easy. From our discussion this video, we can three main important thing. Okay, from the definition of pressure, we can state three different. There are 3 points must be noted when using a liquid pressure formula. Yeah, the first one, the pressure here, rho GH, is not total pressure. This one only pressure from the liquid. If you want to find the total pressure at the bottom of the container, you have to add, yeah, P ATM, P from atmosphere because this one open container, and then plus the P of the liquid. Yeah, so at the bottom the pressure at the bottom, because above it is above it are liquid itself and atmosphere, so the pressure from both of them, P ATM plus P liquid. Yeah. The second one, the height h in the formula indicates the depth. Yeah, I have told you before, the depth measured from the surface. And then the third, a direct result of combining Pascal principle into liquid pressure formula. The pressure is stationary liquid in the same at all points of the same depth. Yeah, in other words, pressure in a stationary liquid change only with depth. Yeah, only with depth. So everywhere, if in same height, yeah, same height, the P1 in P2 here same. Yeah, but we have to notice that if the liquid still at rest, stationary, static fluid. Okay, I think enough for this video about the static fluid part 1. Yeah, this is part 1. We will continue to the part 2. You can like this video, share and comment, and then you can subscribe my channel, and then don't forget to turn on the notification for updates another video. Yeah, obviously the part 2 you have to follow it. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.